if I have a line and I know a couple of points on that line, I know, for instance, that it's going through the point 1, 5 and also through the point -1, 1, I can ask what is the equation of this line and get a kind of sensible answer, hopefully. So from GCSE, I imagine you will know this equation, y equals mx plus c, where m is your gradient and c is the y-intercept. Now that's great, and that certainly does give me the equation of a line, but it's certainly not the nicest formula to use. It's quite clunky, there's a lot of substitution and rearranging, which inevitably means mistakes, we all make them. So what I want to do today is talk you through how to, I guess, use the A-level versions of these things and create the equations of straight lines. Ultimately, we're going to need the gradient and a point, which I'm going to call x1 to mark the x-ordinate and y1. And these are the kind of two key pieces of information we need to create the equation of a line. Now, the examiners will love to hide this information in all sorts of different forms, into contexts, into parallel lines or perpendicular lines. You may end up having to use some calculus to get to your gradient. Lots of stuff to come and lots of ways to find this information out. But ultimately, if we want a line, I'm going to need these two bits of information. Here, I have 2 points. I don't have a gradient. But hopefully from GCSE you do know how to calculate the gradient. It's the change in the y values, which are here. Let's see if I can get this line to work. There we go. Change in those y values over the change in x. It's a rate of change. How much does the y value change for every unit of change in the x value? So here I'm changing 2 units in the x direction, positive x, and I gain 1, 2, 3, 4 units in the y direction. So I gain 4 units of height for every 2 units of distance travelled. So that cancels down to 2 over 1, which we could write as 2 there. So I've got a gradient of 2. And in fact we can generalise that. If you want the gradient, we can say that that's a change in y, so the gap between your 2 y values, over a change in x. So that's x2 minus x1 there. For my point, I can pick either one of the 2 points I have. Both of them lie on the line, but that's the key thing. It has to lie on the line, the equation. We're trying to fix our line, not just to any line that's got a gradient of 2, which can be running off at any sort of parallel distance, but is the one specifically going through the points that I'm interested in. So let's pick 1, 1. Now if I use y equals mx plus c, there's quite a lot of work to be done actually in creating the equation of the line in a form that I'm interested in. So at A level we use this form, which we call a construction form. And this is brilliant because this actually takes you halfway through the algebra that you would be using and the methods and the processes you would be using for y equals mx plus c, and drops you halfway in, so you save half your work. Hopefully in lessons you will see where this formula comes from, but for now we're just going to use it. So this is quite simple now. So I keep my y, because I need x and y in my equation, but I'm going to replace the m and the x1, y and y1 with the values that I've got from my previous part of the question. So y minus 1, because y is 1 in this point I'm using, equals m, which is 2, bracket x minus, and then I've got a minus 1. That's my term there. Just a bit of sorting out here. So multiplying those two brackets out, and then moving this 1 over. So what I've done there is those two minuses have become a plus, and then I've multiplied by 2, and then I moved the 1 over. And that has given me y equals 2x plus 3. And you can see how quick that is. It's really quick. There's a lot less substitution and multiplication and all sorts of other things. And it keeps us quite, keeps it quite neat, I guess. So let's try another example. So I want to find the equation of the line passing through the points -1, 4 and 3, 7. We're going to use this construction form of the line again. So y minus y1 equals m, which is our gradient, x minus x1. So as I said before, I'm always going to need a gradient and a point of intersection. So, not point of intersection, just a point on the line. And I should probably try and learn my alphabet the right way around. There we go. My point that's lying on my line. Okay, well, I know 2 points on my line. That's great, so I'm just going to pick one of them. Let's pick -1, 4 for that one. Gradient, though, not so easy. Let's just imagine these 2 points somewhere in space on a line. There's our -1, 4, and there's our 3, 7. If I'm honest, I've been doing this, using this equation, well, since my own A-levels, and I still draw it out sometimes, just to give myself a bit of an idea, particularly if I'm tired. So my change in y then is 3. I've gone from 4 to 7. So I've taken y2 and I've reduced it by y1. So that's 7 take away 4, that's 3. And my x's have had a change of 4. We've gone from -1 to 3, which is the same as doing this x2, which matches the y2, take away the x1. So in those cases, just to write it out, I've done 7 minus 3 over 3. No, I have not. I have done 7 minus 4. Try and read it. There's a warning to you. You can see how quickly it all gets a bit untangled. Both of my y values, 7 take 4, and then the pair for that coordinate, and then minus 1, which is a gap of 4. So that has given me 3 over 4. So my m value there is 3 over 4. Substituting all of this in then to our equation, I will get y minus 4 equals m, which is 3 over 4 x, minus, and then minus 1. Okay, at this point, don't multiply the right hand side by this 3/4. That is just horrible. It's just absolutely no point. What I'm going to do is multiply by 4. So if I multiply by 4, I get 4y minus 16, 4 times 4, leaving me with 3 lots of this. And I'll just sort that minus out. And that is so much nicer than what we had a minute ago. I'm not having to deal with fractions or anything else. It's really pleasant. I'm just going to move everything to one side actually. So I'm going to go 4y minus 3x minus 17 equals 0. And this is normally the way that the exam board would like you to leave your answer. So where you've got something a bit like, let's see if I can get it written out. There we go. AY plus BX plus C equals 0, where A, B and C are whole numbers. So no fractions. We want whole numbers. And that just means that we're a little bit easier. We're not having to deal with our fractions. We'll just make everything whole and it looks a lot nicer. It's a lot easier to manipulate. I mentioned before that they tend to hide the information that they want you to have, your gradient and your point, inside other bits of information and requiring you to do other techniques before you can access that information. And one of the things they love to do is to hide the information about the gradient in information about a parallel or a perpendicular line. So it's worth remembering that parallel lines have the same gradient. And so you're going to need to work out what the gradient of your line is before you can sort of access that information. So you're going to need to get your parallel line into the form y equals mx plus c so that you can read off what m is, and then it would be the same m for your question. Perpendicular lines sit at 90 degrees to each other, which means that the gradients are negative reciprocals, which let's get that word written out. Reciprocals. Turns out talking and writing is quite hard. Negative reciprocals, which means that if you have a gradient of 3, the perpendicular gradient is minus 1 over 3. Negative reciprocal. Flip it upside down. If you have a gradient of a half, the negative reciprocal is minus 2. Flip it upside down. So again, you might need to get your equation into the form y equals mx plus c and find your m, but then you're going to want to do minus 1 over m to get the gradient for your question. So just some things to think about there.